Let's take the square root of this number and then we'll talk about why it is we do what we do. So whatever your number is, you want to group it into twos because it always takes half as many digits to form a square root. So first thing we do is we look at the first group and we get as close as we can with some squared number. So we're going to do 6 times 6. That gives us 36. 7 times 7 would be 49. That'd be too much. So we put it in there very much like long division. We subtract and we bring down the next group. Now we're looking for a number that goes here, and what we're going to do is we're going to double this number, and we're going to put another place beside it to put another digit. And whatever number goes up here has to be the same one that goes here, and when we multiply those, we get this number. And so this is where you have to do a little bit of trial and error. So we're looking at 335. If I try, how about if I try, I'll try a 3. So if I do 3 times 123, I get 369. That's too big. So let's do 2 times 122, and that gives me 244, and that works. So the number we used was 2. Now we're going to subtract again, bring down the next group. Okay, now we're going to double this number. What we added a 2. So essentially it was just like we had 120 and we added a 2. Okay, well now we're going to double this number. So we're going to double what we added. So that's 122 plus 2. And that's going to be 124. And then we do the same thing again. We make another decimal place, and we're looking for some number that's going to go here and here, and we multiply them. And we have to get as close as possible to 9105. So let's see, if I do 6 times 1246, that gives me 76. Can I go bigger? How about 7 times 1247? That gives me 8729, and that'll work. So we're going to do 7, and then that gives us 8729. We're going to subtract. We're going to bring down the next group. And then again, we're going to double what we added. So we're adding 7 to this number. So 1247 plus 7 is 1254. We're going to put another decimal place. And now we're looking for a number that goes here and here. So let's see. If I do 1, that's not going to be big enough. How about if I do 2? So 2 times 12542. That gives me 25084. That's not big enough. How about if I do 3? So 3 times 12543. That gives me 37629. And that's exactly what we want. We have no remainder. So we used 3 to do that. And this is our answer. Let's talk about why we do it that way. First of all, let's talk about making those groups of 2. Well, so the square root of 100, what I did here is I made the smallest two-digit number and the biggest two-digit number, and if we square those, then this is the square root of this, and we see that if the decimal place is here, you always start at the decimal place and work from the right side to the left. Okay, if we were taking the square root of 100, well, then we would first find this digit and then this digit. The biggest two-digit number is 99. If we square that, we get this, and there's the decimal. We would make our two groups of 2, and as we're forming our answer, this would come up here, and this would come up here. The smallest three-digit number is 100, and we can do the same thing. We make 3 groups. As we're forming our answer, this would go here, this would go here, and this would go here. So we're just making those groups of 2 to help keep our answer digits lined up and help easily keep track of how many more we need. The biggest three-digit number is this, and 999 squared is this if we make our 3 groups. Again, we see we only need 3 digits. And as we're taking the square root of this, we would first get this number, and then this number, and then the last number. So that is why we do the groups of 2. Because squaring always results in twice as many digits or one less than twice as many digits. So why do we do the kind of weird looking stuff out here to the left that we do? So I've used a square here, and square rooting can be perfectly illustrated by the area of a square. Well, this would be the square root of it, a plus b plus c. Should probably put pluses there. And so this number could be depicted as the area of a square, and we're looking for the square root, a plus b plus c, out here. Now, of course, these are place values, so we wouldn't put the pluses in between them if we're actually using numbers, just like, 126 is the same as 100 plus 20 plus 6, just as a little reminder there. So if we look at the first thing we would do, so we have our number here, we look at this, and we make our first entry, and we go ahead and multiply, and we subtract off, and then we bring the next group down. Okay, where did this come from? Where did this number come from? Well, that would be from the gold strip here. So the part that corresponds to B would be 2 ABs and a B squared. So if we write that out here, 2 ABs and a B squared, and then factor a B out, well, then we have A doubled and then B added to it, and all of that times B. And so that's why when we were looking for this number, we doubled this number, so 2A, and then we put another digit place next to it. Now that actually meant 2A plus whatever this was. We're just creating another digits place because this would correspond to the hundreds place, because there's 200, there's 2 places left to go. And so here we're putting a tens place B next to it, but that literally means 2A plus B, not 2A times B. So it's very important to keep that in mind. So our 2A plus B, this is what we're trying to match. Doesn't mean we're going to match it exactly, but we're trying to get as close coming up from beneath it as possible without going over it. So the 2a plus b we could depict as this, as long as, like I said, you remember this is not 2a times b, it's 2a plus b. And so if we put whatever number we choose for b to be up here and down here, and again, let's just put a little plus there, well, then that's going to get us either dead on or as close as possible. There could be a little bit left over that would go over to the next iteration, but that's not a problem. But in this case, let's just pretend it's a perfect square to keep the illustration as clean as possible. And so now we're going to bring down the last group. And where did this come from? Well, that's the gold part of the square. And that comes from two ACs, two BCs, okay, two ACs, two BCs, and then a C squared. Well, all I did was, so here that is, I factored out a C, and that left on the inside two A's, two B's, and a C. And so if we're looking for this last number down here, well, remember what we did with this number? We doubled this and added it to it. So we added a B, so that gave us two A's that we were already in there, and then two B's, and that resulted in some number sitting here. And then we created a place value again for whatever our C was going to be, and that goes here. But again, this is plus C. It is not times C. So just to be real clear. And so then our multiplication gives us exactly this. But of course, there could be, this in my illustration, it's a zero remainder, but it's never a problem if there's a remainder that has to be carried to the next iteration, and you can just keep going. But hopefully that kind of explains why we do that kind of weird procedure on the left, and you just keep doing the same thing over and over. And if you don't know where it came from, it can seem like a very strange operation.